Hello and welcome to all. Today we will discuss about a problem which is related to the principle of moment of force at equilibrium. Here is the question which you have seen on your screen. A half meter rod is pivoted at the center with two weights of 20 gram F and 12 gram F suspended at a perpendicular distance of 6 centimeter and 10 centimeter from the pivot respectively as shown below, which is represented here. Now it has uh, three questions which is related to this section. First one is which of the two force causes clockwise movement. Second one is the rod is equilibrium. This question represent the total moment of force about pivoted end will be zero or not. The direction of 20 gram force is if the third one is if the direction of 20 gram force is reversal, what is the magnitude of resultant moment of force on the rod? Okay, this is the question which is discussed today. This is the diagram in which the this is the half meter scale. Half meter, it means the length of the scale is 50 centimeter, which is pivoted at the middle, which means the distance between these 2 points is 25 centimeter, and this is again 25 centimeter. And two forces, 20 gram force is acted at 6 centimeter from the pivot, and the 12 gram force is acted at a distance 10 centimeter from the pivot, which is in right direction. In first question, in first part of this question, which is asking about which of the two forces causes clockwise movement, as we know that if force is acting in this manner, this is trying to rotate in anti-clockwise direction, and if the force is this arrangement shows the moment of force in anti-clockwise direction. In this diagram, the pivoted point is represented at C, and we have to calculate the moment of force about the point C. If you see that the 12 gram force is uh, acted in right direction from the C, and 20 gram F force is acted in left of the C, then the tendency of 20 gram F force is trying to rotate in this manner. If we make another diagram to understand the direction of force, this is the pivoted end, this is the 20 GF force, and this is the 12 GF force. The 12 GF force will be trying to rotate the meter scale in downward direction in clockwise, whereas the tendency of 20 GF force is trying to rotate in this direction, which is anti-clockwise direction. Here 20 GF force causes clockwise movement, and the magnitude of this moment of force is 20 GF into perpendicular distance of this force from the pivoted end, which is 10. And this is can be calculated as 12 GF into 10 centimeter, which is 120 GF centimeter. uh, GF is known as dyne. Then this is the uh, unit of this moment of force, which is dyne centimeter in clockwise direction. Then we have to found that is the rod is in equilibrium. Is the rod is in equilibrium, which can be verified by if the anti-clockwise moment of force will be equal to clockwise moment of force. That is moment of force due to 20 kgf will be equal to moment of force due to 12 kgf about the pivoted end C. This can be written as 20 into distance of 20 kg of force from the pivoted end is 6 centimeter, and the distance of 12 GF force is 10 centimeter. 20 into 6 and 12 into 10, 120 kgf centimeter, kgf centimeter, which is same therefore rod is in equilibrium. In the third part of the question, it is said that the direction of 20 GF force is reversed. What is the magnitude of the resultant moment of force? Then the diagram would be like this. This is the pivoted end. 20 GF force is reversed, which means the 20 GF force is acted in upward direction. and there is no change in the direction of 12 GF force, which is acted downward at 10 centimeter distance from the pivoted end. Then we have to find net moment of force about pivoted end. Which is moment of force due to 20 GF plus moment of force due to 12 GF. The tendency of 20 GF force is trying to move this bar or meter scale in clockwise direction, and the tendency of 12 GF force is trying to rotate also in clockwise direction. Then the net force is in clockwise direction. Therefore, the moment of force by these two forces can be adding up 20 into 6 plus moment of force due to 12 GF, 12 into 10, 120 plus 120 equal to 240 GF centimeter. That is 240 9 centimeter clockwise direction. Here is the next question, which is based on the concept of principle of moment of force, which is asked in uh, board exam 2017, which states that a uniform half meter rule balances horizontally on knife edge at 29 centimeter mark, where when a weight of 20 GF is suspended from one end. Draw a diagram of the arrangement. What is the weight of half meter rule? First of all, we have to draw a diagram for this question. Then we have to find out the weight of the half meter rule. Okay. Then first of all, we have to draw a suitable diagram for this question. This is the diagram according to the question. In question, a uniform half meter rule. This is the half meter rule having length 50 centimeter. The weight of the rule is acted in the middle of the rule, which is at 25 centimeter from both of the ends. W represents the weight of the rule, which is acted at 25 centimeter from one end. And in the question it is given that a knife edge support is present at 29 centimeter mark. This is the 29 centimeter mark. After that, another weight of 20 gram is suspended from one end. Uh, 20, gr- 20 GF force is suspended from one end. For equilibrium condition, as we know that anti-clockwise moment of force will be equal to clockwise moment of force. The moment of force always calculated about the pivoted end. In this question, the pivoted end is 29 centimeter. W is provide or causes anti-clockwise moment. Therefore, for balancing, the 20 GF force will provide the clockwise moment. Then the location of force is at this point, at this end, in downward direction. Then for equilibrium condition, uh, anti-clockwise moment of force due to W is balanced by clockwise moment of force due to 20 GF force. Then anti-clockwise force W into distance of W from the pivoted end is 4 centimeter, because location of W from this end, from zero end, is 25 centimeter, and the distance of pivoted end is 29 centimeter from the zero end. Then the distance between W and pivoted end is 4 centimeter. W into 4 will be equal to 20 into 50 minus 29 centimeter, from 0 to 29 and 29 to 50. Then the distance between this pivoted end and 20 GF is 50 minus 29, which is equal to 21. Then W will be equal to 20 into 21 upon 4. Then weight of the stool roll will be equal to 105 GF, or 105 dyne. Dyne is the CGS unit of force. In next lecture we will discuss about topic center of gravity and location of center of gravity of various geometric shapes. Hope you enjoy the video. If you have any query regarding this concept which I have taught earlier, you can email me at amrendra038 at the rate gmail.com. Amrendra, AMRENDRA 038 @gmail.com.